सर प्रेजेंटेशन
हाँ।
अदर करना है और आपका स्क्रीन इधर आएगा सर। अब जो इफ यू आर राइटिंग ऑन बोर्ड आई विल कम एंड स्वैप द स्क्रीन्स।
Okay, okay, and I will use slides. हाँ.
सर ये मौसम चलेगा।
अच्छा ठीक है, I will preferably use this. ठीक, but this should not come in between. So are the participants here?
Check this.
हाँ, ठीक है. हाँ, you just see somebody is outside again. So good afternoon everybody. So as we have to give more time, more lectures to the foreign expert, Professor Pota. So my two lectures we are merging into one. So now 2 to 3:30. So that is grid-connected solar PV system with tutorial. We'll cover here. This light is required. Just see from the side. Okay, is it visible from the last? Okay. So here I teach distributed generation and it's with laboratory for the MTech student. So for MTech student they'll find few topics which are common, but I will touch upon the topics where research is required and cover the points on which tutorial is best. Okay, so few images are shown on the title slide. Grid connected solar PV system. On the left hand side you find that this is a rooftop solar. So the area in which my scholar Jay is working for his MTech project. Another you find a ground mounted grid connected solar PV plant. This rooftop plant. In addition we have in India canal top 1 megawatt in Gujarat. पूरा canal cover कर दिया है. That is only one in canal top. And floating solar, the area in which my scholar Mamta, she is doing PhD, and the Sai is doing MTech project. So all these systems are grid connected. Okay. Then what is common and how to design a grid connected solar PV system? With some PV basics, we will consider the design steps and what are the parameters which are important when performance of such a system which is connected to grid is to be evaluated. So there are technical parameters, okay, as well as economical parameters. So technical parameters of the grid connected solar PV system include performance ratio, capacity utilization factor, determination of the final yield, array yield, reference yield, so on and so forth. In economic analysis, one has to cover the life cycle costing because the panel life is 25 years. Okay, and the output from the plant will not remain the same. Because I attended one course at Electric Engineering Department, IIT Bombay. Long back they had a 2 kilowatt rooftop PV plant on the terrace of the Electric Engineering Department, IIT Bombay. And after several years when the course was organized, they said that now the output is only 1200 watt. Now the factors which are very important that brings out the degradation. So degradation factor is very important when you carry out analysis. The analysis of such a plant is different from the analysis of thermal power plant. Okay, thermal power plant or any plant you will have fixed cost and variable cost. Okay, and in thermal power plant fuel cost is the major variable cost apart from the operating and maintaining expenses, labor cost which come under variable cost. But here there is no fuel cost involved. So why renewables are attracting the attention of scientists and engineers and even a common man? The reason is that these are renewable, means they are not going to be exhausted. Then secondly, they are not polluting environment. So here we get few benefits. Then there are some disadvantages. That solar energy is a source which is as if the dilute energy source, because the origin is from the sun and it reaches the earth. So several thousand kilometers distance, and people are working on the concentrated solar power. Means just as we used to concentrate during our school days to burn a paper, okay, by using lens, there we were doing the concentration of solar rays. So on a larger scale, the solar energy is concentrated and you get high temperature that can be used for the industrial purpose and heating and steam like that. So few basics I will cover, not all the slides, and then I will touch upon the topics related with this. This next, how we are doing this from keyboard से अच्छा from this keyboard. Okay. I had planned something like this, but looking at the time constraint, then I will have to limit the content. Overview of solar PV resource, because source is solar PV. Solar energy which comes from the sun. So sun gives us light as well as heat. Okay. And here we are more interested in this, the solar PV. So instead of solar thermal route, where solar energy is converted to heat energy that you find in solar water heater. Then the solar PV is another route, and where solar cells will be used to convert the solar energy into DC electricity, then through inverter into AC electricity. So as a resource, okay, what are the limitations? Because still the PV cells, they have not achieved very high efficiency. Perovskite solar cells, recent trend, they are used around 21%, 25%, they say. But always remember, there are two types of efficiencies when any new technology or any new material is used. One is laboratory efficiency, which you may find on the literature, 24%. And another is field efficiency, when the same panel is kept in the field installed in the grid-connected PV plant. So we have here several duties as a faculty. Teaching is one duty that includes undergraduate, postgraduate theory and practicals with projects. Then research is another, so where we guide the PhD scholars. Research also, there are different types. Academic research means the scholar is working to meet the requirements of the PhD degree, to get the PhD degree. That research work leading to PhD degree as academic PhD. Others are some sponsored PhD, means where the candidate gets the fund from an industry, so industry sponsored, or it can be under the DST sponsored or any agency, funding agency sponsored, the research. Then teaching, training, and training includes conducting training programs. Earlier myself, Lokhandi sir, we had organized 2-3 programs. So self-finance programs we had organized, and now this is under GAN program that we submitted a proposal with the help of Professor Pota. Then there was few comments that we were addressed with his help, and it is through now. So for all these GAN proposals, GAN stands for Global Initiatives of Academic Network. IIT Hyderabad is the center, and we get a sanction letter with the signature of their director. Okay. And they have a very strict schedule that immediately after sanction, they expect that brochure should be ready and sent to them so that they will upload on their website. Even this YouTube link live streaming is done by them. Then other also their formalities we have to complete after the course. First we have to see that the first part in this in the plant is solar panels. And what are the advances in the solar PV technology? Okay. Earlier we had monocrystalline, polycrystalline. Polycrystalline modules you will find in number of the installations, whether it is a standalone PV street lighting system or it is the grid connected system. So then monocrystalline you will not find to that extent. Okay. So it has slightly higher efficiency, and thin film was introduced at Chandrapur. They have solar power plant. Long back they had 2 megawatt plus 2 megawatt plus 1 megawatt. So we used to visit that plant along with students long back, but now that we have several installations within the campus, so that is not required. So we will see the trends in the PV okay, modules. That is second point. Then after modules, so the terminal box will give you DC and how these panels are connected in series to form one string and how there are parallel strings and how do you decide the rating of the inverter and number of modules in the string as well as number of strings. So some numericals will be covered, and then after this you have DC combiner box, then you have the delta make inverter, okay, which is a string inverter, and that inverter will do three functions. So DC to AC is one, synchronizing with the grid, because all the developers of the renewable energy plant, they have the responsibility that they penetrate pure sine wave into the grid, okay. So then that box, so the grid tied inverter it is called as, it will have DC to AC, it will have synchronizing and MPPT, okay, three functions. So about MPPT also we will discuss as the time permits. Sir has already touched upon, Logan is about MPPT. Then design procedure, some steps that I got from one of the reference. हाँ चलेगा. Okay, अच्छा that. Otherwise
You can speak from this.
Okay, okay. हाँ. So design procedure steps. This presentation will be with you. Okay, I will consider only those slides which are required. Impact of derating on PV modules output. How output reduces with derating. How it reduces with dirt. All these factors. Then some conclusions and our publications. Basically, you will get under the Google Scholar. Okay, okay, I can start here. Okay, thank you. So we'll go accordingly. Sources are renewable and non-renewable. So solar photovoltaic or solar thermal, wind, geothermal, ocean, tidal, so on and so forth. Non-renewables, IC engines, combined cycle gas turbine, combustion turbines, micro turbines which are gas turbines. So do you know the thermodynamic cycle on which the gas turbines they work? The Rankine is for thermal, okay. It is Brayton cycle, BRAYTON, Brayton cycle for micro turbines, gas turbines, fuel cell. Now, why we are considering both categories? Because there is a need of a hybrid, okay, plant which will have solar plus wind, solar, wind, battery, solar, wind, fuel cell. Now, fuel cell comes under non-renewable. It is using fuel. Okay, so solar power plant can be like a off-grid plant, standalone solar street lighting system, or they can be grid connected or hybrid. In hybrid, you have minimum two combinations, two sources. Floating solar, okay, our scholars are working, but we suggest them that you think of, okay, proposing a floating solar plant on the hydro power plant reservoir at Koyna Dam. अब हाइड्रो पावर प्लांट सर्च करो कहाँ है, उसके पानी पे आप फिर तरंगता हुआ सोलर फ्लोटिंग सोलर प्लांट का आप सजेस्ट करो, प्रपोज करो. ओके, so hybrid is required so that both sources are available to meet the if one is not available. Like solar is available during the day, okay, and then you require battery backup. So now grid connected PV systems are catching attention. If you visit IIT Delhi, Professor Bean Singh, who is guiding PhD scholars in the area of power electronics and renewable energy connected to grid, they are putting huge battery bank, energy storage, grid connected setup में डाल रहे हो research work for the stability of grid. Okay, all these pilot scale studies are done in lab. So many times students are confused that distribution generation. So therefore the term is distribution generation should not be confused with only renewable. It has both renewable plus non-renewable. Okay, that is in brief. So then which source is suitable where? You must know. अभी सोलर पैनल आपको 10 वाट का भी मिल जाएगा जिसके ऊपर आप एलईडी लाइट चलाओ, पर विंड टर्बाइन नहीं मिलेगा 10 वाट 50 वाट का. You will get in 500 watts. Okay, so you must know the rating few watt to several hundred kilowatt for solar PV, and what is the interface required when you are talking about grid connected utility interface. Okay, so this is given. So first solar PV, wind, geothermal, ocean, they come under renewable. Remaining from IC engine onwards up to fuel cell, they are non-renewable. Okay. At IIT Bombay, I have seen fuel cell setup in the Applied Power Electronics Laboratory when I attended one such training program in 2013. Professor Vivek Agrawal, he was a coordinator. And they have purchased fuel cell from a foreign country, the Ballard make, and they are only interested in taking the using fuel cell as a source, plus minus a DC source. And they have power electronics engineer researchers, they have developed the hardware for this interface, power electronic interface. So they developed some problem, and for which they had to send it again to US, and then it was okay, now shipped back. So fuel cell, okay, where the characteristic they depend upon the supply of fuel. 100% supply hai, 75% hai, 50% hai, 25% hai, like that. Okay, and very pet question in exams, college exams are, what is the difference between fuel cell and solar cell? So this is just basics. Then these are references that suggest our students you should read references, so you come to know where are these papers published, what are those journals, magazine. Because now for those who are new to this, because I am not having any idea whether you have done any course on solar. If you start from the sun, okay, the solar radiation at the top is shown as a short wavelength. Okay, the wavelength is short. Then the first, okay, is the extraterrestrial region above the atmosphere. Part of the radiation reflected from atmosphere is shown. Then we in the atmosphere we have O2, CO2, O3, H2O, CO, dust, etc. Then because this dust gets accumulated on the panel, and that reduces the efficiency of the panel. So only maintenance is regular cleaning. There will be bird droppings, okay. There will be shadow from the nearby a building or tree. So one has to inspect the site. If it is a rooftop PV plant, you have to carry out the inspection of the roof, whether the roof will be able to bear the concrete structure, and above concrete structure there will be module mounting structure, जिसको आप fabrication कहते हैं, वो fabrication structure पे रहेगा panel. So whether the roof will be able to bear that load, there should not be seepage. Okay. So when it is installed on ground, soil inspection करना पड़ता है जो सिविल इंजीनियरिंग के लोग करते हैं. कहने का मतलब है रिन्यूएबल में काम करना हो तो टीम को काम करना पड़ता है, और सिविल इंजीनियर, इलेक्ट्रिकल इंजीनियर, एनवायरमेंटल इंजीनियर सब साथ में चाहिए. इट इज इंटरडिसिप्लिनरी एरिया. We start design everything by giving latitude. So latitude we have first studied in geography, school geography. Latitude, longitude, geographical information is required, whatever site that you choose. Then the radiation that comes in the form of straight line, light beam. It is beam radiation, that is around 85%. The remaining, which is reflected from ground, okay, that is called as long wavelength. Some of it is diffuse. Diffuse means which is not connect like a direct. It is a diffuse one. That will around 15% or so. We are more interested in the beam radiation, okay, and how we can use this, because it is freely available. Okay, so throughout the day, so how we can make use of this, and for the energy needs in the villages as well as in the urban areas also. So same thing is shown here, how it reaches Earth's surface. So from short wavelength from the sun and then to the earth, reflected from the earth as a long wavelength. Okay. So wavelength is very important, because when you study electromagnetics, so there we cover that solar energy spectrum is a electromagnetic spectrum having ultraviolet region, infrared and visible. Okay. So based upon the wavelength. Okay. So these are the three important laws. Planck's law, okay, that gives emission power per unit of black body. They consider sun as one black body, earth as another black body. Black body is a perfect emitter and perfect receiver. So that is analogy that is used. So this theory is available, Stephen Boltzmann law of radiation, okay, where E depends on area, then sigma, that is Stephen Boltzmann constant, and temperature, which is given of the black body, that is in Kelvin. Then third is Wien displacement rule, indicating lambda max in micrometer or micron, 2898 by temperature in Kelvin. So with this we start our content so that they are known, and such a spectrum is available. As an assignment, our student earlier, senior batches, they have done this everything in MATLAB and plotted this. So that way we give assignment to have practice in MATLAB, M code का होगा या Simulink का होगा, and they remain in touch with the equations, and so that they remain so they are able to understand the equations and reproduce them very well, very well. Extraterrestrial solar spectrum has three regions: ultraviolet, visible, infrared. जो हम देख सकते हैं वो visible है 47%, okay. Then infrared, which is emitted from the earth, that is 46%. And here they have shown that sun is a black body with 5800 Kelvin, such a high temperature, hot mass, thermonuclear furnace, where the fusion occurs. Okay. Then the wavelength is shown on x-axis versus the intensity, which is measured in watt per meter square micrometer. So then Earth is another black body with 15 degrees Celsius, means in Kelvin 273 plus 15, that is 288. Okay. So then extraterrestrial solar insolation आपको निकालना है, ये equation use करो, इसका MATLAB code develop करो, you will get the graph for this. The value is 1.353 as per NASA, but considering scattering and reflection, the standard value is 1 kilowatt per meter square. That is required when you consider standard test conditions under which the module is manufactured. I had been to the Gen Solar factory at Jalgaon because one of my friend, he was a faculty at the GH Raisoni College, Jalgaon, and he invited me for a guest lecture. I said I will come for a guest lecture in that STDP, but with another I have expectation that can you arrange my visit to the Gen Solar plant. He said we have very good relations with them and they sponsor our student competition, prizes and other things. So first half I covered my lecture, and after lunch we were there. For 3 hours I was there, but they had not allowed me to see to see and enter into their lab to see how the modules are manufactured. वहाँ अंदर आप नहीं आ सकते बोले, आप ये हॉल में बैठो, टीवी पे देखो, टीवी पे पूरा उन्होंने वीडियो दिखाया how they manufacture this, because they wear special dress, उनका वो टेम्परेचर मेंटेन करना पड़ता है. स्टैंडर्ड टेस्ट कंडीशन दिस से that 25 degrees is the cell temperature when it is manufactured. 1 kilowatt per meter square is this, okay, that solar irradiance, and air mass 1.5. So we will come to that definition. The clearness index is another, which is the ratio of monthly average daily global radiation to monthly average daily extraterrestrial radiation, which is outside the atmosphere. Okay. Some example using this formula you can go whenever you are free. Another also example, air mass is the second test condition, standard test condition. What is it? It is a ratio of the path lengths. So you find a man that is standing on the earth here. Okay, sun position you have to track from the morning to evening. Okay, sunrise to sunset. Okay, and you know that in winter sun rises late. Sunrise is 6:45 होगा. Okay, the locus of the sun, that is to be tracked, because all the time you want that sun rays should be perpendicular to your panel. Your panel is fixed. Generally it is fixed equal to latitude angle, and when it is installed on the ground mounted or rooftop, because the concrete blocks are there above which the module mounting structure, and Professor Andare tomorrow will discuss the vibrations in the structure, and above the structure there are the modules. The modules are connected in series, okay, to form one string. Now air mass is another definition, and which is given by this formula, and when this angle beta, which is measured from the ground, it reaches, okay, at 90 degrees, means sun is overhead, उसको कहते हैं sun is at zenith, means overhead, 12 बजे, so that is beta equal to 90, so sin of 90 you have to put, and that will give the value m equal to 1. Here they have mentioned for the sun directly overhead, m will be 1. So for the standard test condition is again at 1.5. Okay. Then effect of air mass, here they have shown that how solar spectrum will be different if air mass is 0, which is at the top, air mass equal to 1, air mass equal to 5, how that peak is coming down. Okay. Greenhouse effect is very important because we find that glass is the top surface, okay, and in your solar water heater also. Then the glass being transparent, the radiation reaches the black absorber. So we want the absorber to be painted with black color, We have one patent with Professor Lokhande and other colleagues, solar cooker, and it got several awards. Recently we got one award from the Ministry of Environment, Forest and Climate Change, because they floated one competition that was for the Save Energy theme. They have one Mission Life as announced by Prime Minister. Under Mission Life, life is a short form for lifestyle for environment, means our lifestyle should be environment friendly. So you should use minimum plastic and save energy, save water. So many themes are there. So from VNIT under Save Energy we had participated, myself, Lokhande sir and the Savarkar from Mechanical. So then it was shortlisted and they asked us whether you will join for final presentation online or physical mode. We preferred online and we joined, and only it was delayed. So it was scheduled around 2 o'clock in the afternoon, but it started at 6 p.m. So we were about to leave, then they said, oh, VNIT Nagpur. And that the Save Energy theme, how we can save energy using the patented solar cooker, which is regularly used by Lokhande sir at his flat. So that got the first award, and they invited all of us to the on World Environment Day. We were at Delhi. So Lokhande sir will share with you that the patented solar cooker, where our students they help us in displaying in the local exhibition or outside VNIT also. So this greenhouse gas effect is shown, incoming light, that is shown reaching the Earth's surface. Then infrared is invisible, which is emitted from the Earth's surface, and part of the light is absorbed by CO2 and part is back radiated to ground. This is general greenhouse gas effect that one has to understand, and some definition like solar declination angle. Here 4 important days, and I shared with Dr. Makarand Lokhande that we should take readings on the patented solar cooker on our terrace on these days: 21st March, 21st June, we call it the longest day in year, then 21st September and 21st December, and share results with the audience, our students, as well as in any exhibition, so that people understand the importance of 4 days and how solar cooker can be utilized, because that is basically designed for a rural family who do not need any LPG gas or do not have any connection like this. Then these 4 important days, and see the sun earth distance. So for summer solstice 152 million kilometer, then it is 147 for winter solstice, which is winter solstice means December 21, which is the shortest day in a year. Others are equinox. This declination angle, all these equations students have put and developed MATLAB program to verify the bottom table, that the angle varies from the, you see the last December, the December is minus 23.4, it is shown here to the on June 23.4. So in this table they have considered 21st of every month. Only care you have to take if in a numerical we ask the students that if it is a leap year 2024, February will have 29 days. तो आपको यहाँ जो दिया है इन्होंने कि for January 1 it n equal to 1, so for February 1 n equal to 32, but if it is a leap year, then we have to consider this for January otherwise is 31, February otherwise is 28, only for leap year 1 will be added to 29, and for 1st March accordingly the day number is decided and that you use as a n in the formula. That is the only variable that is required. So here if you look at the formula, 23.45 that is shown in June and minus 23.45 will be in December. That graph will be there accordingly. Then altitude angle, man is standing on the earth, the altitude or angle beta that is measured, you find that this local horizontal, and sun is zenith means at 12 noon, and the sun position is shown here. We have calculated earlier declination angle, L is the latitude, and beta n they call it altitude angle, which is 90 minus latitude. So you should know latitude at the site like Nagpur 21 degrees, and delta you calculate depending on the previous the formula that depending on n you decide the delta. Then the solved example is there, one can go through this. Azimuth angle is very important because it is the angle that is measured. Look at this solar panel site, we have east and west side. So they have mentioned that east of south the fires will be greater than 0. West of south, this towards west, fires will be less than 0. According fires is indicated here, and from sunrise to sunset the locus of the So, and that is shown, and around 12 noon that position is shown. Okay. Solar PV is the topic. We do want solar cell. Now we come to this. Sir has discussed in detail about the PV cell, and okay. So we have here the sunlight facing the top layer, that is N-type layer. So the thickness of N-type layer and thickness of P-type layer will be different, but N-type will be facing the sun, and you have anti-reflection coating because you don't want that the losses due to reflection should be more. You want to reduce them. Okay, that electrons will flow from minus terminal to positive. You can have external load, and what happens that the principle of this, okay, can be better explained through 3 steps: absorption of light energy in the form of photons, then the creation of whole electron pairs, okay, and due to the potential present at the junction, they get separated, okay. And we find that this PV cell, which is the heart of our here, can be represented through an equivalent circuit. In electrical engineering, हम कहते हैं कि equivalent circuit ये जन्म कुंडली जैसे है, उसके सिवा कुछ नहीं होता. Whatever you want to study through equivalent circuit, and always you will find ideal equivalent circuit and practical equivalent circuit. So if you understand them, then the students they can answer any questions, okay, in any seminar or anything. So their PV cell, which is shown on the left hand side, is which is connected to load. So ये PV cell उन्होंने बताया current source in parallel with a diode. That is PV cell. Don't call it PV cell as only current source. It is a current source in parallel with a real diode. Okay. So and load is connected here. Now here the graph shows that if it is a dark, then no radiation, the graph will come down. Otherwise, as per the watt per meter square value, it will go up. So it is a PN junction that is shown. The diode current equation you require. Okay, symbol is there. Diode, the characteristic that you know. Sir has talked about this. This leakage current I naught is shown. And then use this okay, the diode current equation, and they are considered at 25 degrees, which is the standard test condition. The connection between cell current and voltage in an ideal solar PV cell is inaccurate. Why? Because it ignores the impact of internal resistance. Then we have to go for practical circuit, and there you find additional 2 resistances. So आपका ये current source in parallel with diode तो पहले भी था, अभी ये parallel resistance ऐड कर दिया है, which is very high, and series resistance low. So RP is very high compared to series resistance. They are given by manufacturers. Otherwise, the measurements are to be done because you have 2 unknowns. So you have to take the readings to find out them. There are several papers available. The serial resistance is mainly sum of contact resistance on the front and back surfaces. Metal surfaces are there, and resistance of the bulk and diffuse layer on the top. The shunt resistance represents a high conductivity path. So here I mentioned at the bottom, series resistance is the representative of internal resistance, which was not there in your ideal solar cell, whereas leakage current is shown by the shunt resistance. So therefore there is need of practical equivalent circuit. Researchers, what they have done, I will share about this with our MTech students, those who have studied this. Such a characteristic you will get, and that for the zero voltage you have the current, that is short circuit current. If short circuit current is 3.4 ampere, your fuse should be of 5 ampere. उससे ज़्यादा रहना चाहिए. Okay, and another is open circuit voltage, for which your current on the y-axis is shown as 0, open circuit, and as it is a constant current source in parallel with diode, you get such a characteristic. And we are going to talk about this knee of the characteristic, this point, and you have to plot simultaneously PV characteristic, as sir has already covered, and this point will correspond to the peak point on the PV curve, and if you take from that curve the projection, this will be Vm, and corresponding dotted the projection on y-axis is Im. So we are going to come to this, and this is very important because our field factor. हाँ, now researchers what they have done, आपके इसमें पहले इसमें वो आइडियल सर्किट में ये सीरीज रेजिस्टेंस पैरेलल रेजिस्टेंस नहीं थे, करंट सोर्स इन पैरेलल विद द डायोड. बाद में आपने सीरीज रेजिस्टेंस पैरेलल रेजिस्टेंस डाल दिए टू मेक इट मोर एक्यूरेट इक्विवेलेंट सर्किट, एंड देन दे एज इन दिस equivalent complex equivalent circuit you have only one diode, they tried with second diode in parallel, third diode in parallel. If there are 2 diodes, then you will have 7 equations, equation बढ़ जाएंगे आपके. Okay, so with one diode we can give the assignment to the student, plot the VI characteristic or PV characteristic, develop a code, or in simulating what you can do using solar cell block. Then try with 2 diodes. Okay, So this two diodes additional term will be there because ID1 तो पहले एक ही था, डायोड एक ही था, अभी ID2 ऐड हो गया, तो ID2 that is added in these equations, and two diode model requires 7 unknown parameters as mentioned in the last line. So that can be tried. Even recently I have seen one paper in the Springer yesterday, 3 diode also they have tried. So they want to see that okay, what they achieve and they make a comparison. So whenever you are doing research, try to see that you present results in a comparative form, whether it is BTech result or project or MTech or internship report, आपको कंपेयर करना है आपके रिजल्ट. आप प्रपोज सॉल्यूशन कुछ दे रहे हो, एक कॉलम रहेगा, you have to compare with already published in the literature, and then you say my results are very close to that and I am suggesting proposing something new. Okay, solar cells, when you connect them in series, so here they have shown 4 cells, their voltage will add 36 cells, voltage will add 36 into 4.6 per cell, that is given. So number of interconnected cells will form one module and number of interconnected modules will form array. So we require array, okay, string in grid connected plant. Okay, so this is shown that module cell से module बनता है. So see, our body we have the cells or tissues. Okay, we talk about the neural networks. So origin is from our human brain. So I think it is essential that we understand our human body, how it has been designed, and how people are okay replicating that. Recently I read one paper where MPPT technique is using Alibaba and 40 thieves. Alibaba I store कथा माहिती है. That technique is used. One professor from SVNIT Surat has developed one technique for MPPT, teaching learning best optimization. ऐसा मेथड लगे आप, teaching learning best optimization. So teacher says the learner may understand, may not understand unless he or she reads from the book. Teaching learning best optimization. So there are several MPPT techniques. Okay, so these are very elementary slides just for revision. Then these are tilt angle and orientation. ये दो फैक्टर बहुत इंपॉर्टेंट. ओरिएंटेशन साउथ रहना चाहिए क्योंकि इंडिया इज इन द नॉर्दर्न हेमिस्फीयर. अगेन यू हैव टू गो टू वर्ल्ड एटलास. वर्ल्ड एटलास हमने कब पढ़ा? स्कूल में पढ़ा. स्कूल में बोलते थे, हाई स्कूल में वर्ल्ड एटलास लेके आओ. वहां से हमारा एजुकेशन शुरू हो गया रिन्यूएबल अलॉन्ग विद साइंस. सो देन ओरिएंटेशन टुवर्ड्स साउथ, ओके, इन इंडिया, एंड टिल्ट एंगल इक्वल टू, यू वांट टू कीप फिक्स्ड लैटिट्यूड. आपको चेंज करना है एज पर सीजन, बट सीजन इज नॉट फिक्स्ड. कभी बारिश होती है, अदरवाइज इफ यू रेगुलर सीजन लैटिट्यूड +15 करना है एंड विंटर में, एंड लैटिट्यूड -15 करना है समर में. 3 पोजिशंस, और यू कैन ट्राई विद द सॉफ्टवेयर. ओके, व्हाट इज सो then just by looking I want my student to understand whether it is a polycrystalline or monocrystalline. Left hand side of the diagram monocrystalline show there are white dots दिख रहे हैं आपको, काफी डॉट दिखे, काफी white space है, इसका मतलब वो monocrystalline. If the area full covered as shown on the right hand side, most of them are polycrystalline, also called as multicrystalline. आजकल तो new technology is coming, but हाँ. So what are the development? पहले आपको एडवांसेस इन मटेरियल साइंस पढ़ना पड़ेगा. नैनो मटेरियल आ चुकी है इसमें. Therefore interdisciplinary approach is very important. In one of the discussion I suggested to Lokandi sir, मतलब कि you have long service here, let us propose Center for Interdisciplinary Studies in Sustainable Energy, so that we can invite our colleagues and scholars from chemical, mechanical, electrical, electronics, सब सस्टेनेबल एनर्जी के लिए इंटरडिसिप्लिनरी सेंटर बनाओ. That way, because approach is like that. In IITs, one guide is from electrical, another from another department. दोनों guide रहते हैं. So here also we have interdisciplinary board. So that is the need. Okay, thick silicon. Okay, already I have seen multicrystalline. You know. Then thin film. Okay, so थिक में दिखाया 200 to 500 माइक्रोमीटर था थिकनेस कम हो गया, थिन 1 to 10. हेटेरो जंक्शन, कैडमियम टेलुराइड, कैडमियम इंडियम सल्फाइड, होमो जंक्शन, पॉलीक्रिस्टलाइन, मल्टी जंक्शन, गैलियम आर्सेनाइड, इंडियम फॉस्फाइड. People talk, we talk about this so much material, so much, okay. Do they talk? Then what will happen to the panel? Is it environment friendly? There should be some policy. जैसा कि सोलर रूफटॉप में पॉलिसी आ गई है, our professor who retired on 30th June, he constructed Bangalore here. He has installed 5 kilowatt rooftop. बोले पहले 1 किलोवाट के लिए मुझे 30,000 सब्सिडी मिली, दूसरे किलोवाट के लिए 30,000, थर्ड किलोवाट के लिए 18,000. 30 plus 30 plus 18. Government is giving 3 kilowatt onwards 78,000 subsidy. Just to encourage. तो जिन लोगों को इसकी प्रगति देखना है अपने देश में, तो उनको पीएम सूर्यघर, जस्ट यू सर्च इन गूगल पीएम सूर्यघर, you will get site where everything is there. So we need to understand this very well. These are what we are talking about. Okay, what is emerging is perovskite and organic PV. So what challenges are two. सोलर सेल की एफिशिएंसी कैसे बढ़ाओगे, कौन सा मटेरियल यूज करोगे. मटेरियल के लिए यू हैव टू कॉन्टैक्ट मेटलर्जी डिपार्टमेंट, देयर फैकल्टी. ओके, एंड देन हाउ the cost can come down, which is already coming down. Okay, bifacial is a new technology, but not available in 10 watt and 50 watt and 100 watt. इतने कम watt रेटिंग में नहीं है वो. Where from the back side you get 30% benefit, 70% from the front side and 30% which is shown on the black. So this I attended a webinar during lockdown, bifacial module technology with transparent backsheet. Vikram Solar is a branded manufacturer, you can see their website. Conventional में क्या हो रहा है, okay, monofacial means only front side. Okay, what is reflected from the ground is not of any use. Therefore bifacial gives 5 to 30% more, okay, the energy gain, but rating of will be around 365, 425, 500 watt peak. तो 50 watt में नहीं मिलेगा आपको ये. अच्छा, so if you see any string, so across this the solar module you will find one diode that you can connect your multimeter and check. So that diode which is there, so we call it as a bypass diode. Okay, across string, here they are shown across the panel, and one diode which is shown here at the end of the string called as blocking diode, that they call it string diode, and this is dark is called as bypass. It is bypassing. You require bypass provided this is shaded. So I guided one MTech student and he presented paper at NIT Bhopal, this student conference, on the partial shading conditions of this the PV module, and he considered several cases and then simulated like this. तो ये blocking dot जो दिखाया है, ये dark वाला नहीं, दूसरा, that has to block, because if you are connecting through a converter to charge a battery, you don't want reverse current, उसको block करना है, इसका नाम blocking रख दिया. Bypass means the solar panel is shaded, then you should have diversion, so bypass route is there. So that is basic concept and their functions are important. Now when you plot IV PV characteristics, they are shown here. Now the top of the PV curve, that is showing that maximum power, also called as rated power here or PM. You take projection on the bottom curve, where it intersects IV curve, there, okay, you mark that and take projection on x-axis. This is the voltage, rated voltage or VMPP, it is called as this rated current which is less than IC and IMPP. Now the squareness of the cell is very important, what I have shown with the red color shaded area. And I have mentioned here fill factor around 70 to 75% for crystalline silicon solar module. One can check from their manufacturer's data sheet, sticker that is pasted on the back, whether this value is there. Typical for multi-junction amorphous silicon, it is closer to 50 to 60, it is reduced. Amorphous silicon means that thin film, it is not so popular. Though, okay, so that thin film size is reduced, but this Somera grant, आपको manufacturer की website देखनी पड़ेगी. नई technology है that they are indicated here, that passivated emitter rare contact PERC, पर यहाँ वैटेज मिलेंगे आपको 360 वैट से 385 वैट, 100 वैट में नहीं मिलेगा ये पैनल. So you must know कि which rating of panel should be suggested. Okay, up to 385 watt power output it gives, 72 cells monolithic, okay, monoperc they call it. Okay, so monocrystalline, passive emitted rare contact, new technology is there. Okay, you can see this, the details. Then what is the impact of PV module mismatch? We had such 75 watt 6 module on the terrace, and what happened, one of the module was broken because this is a campus area near to Ambadari. Monkey, they keep on coming here, monkey ने dance किया, break हो गया. To replace that module, The Professor Khedkar has spent that time 15,000, but make was different. और उनका ओपन सर्किट वोल्टेज नया मॉड्यूल जो लगा है बीच में और पुराने 5 इसमें थोड़ा अंतर था, तो मिसमैच आ गया. ओके, सो व्हाट आर द रीजन फॉर मिसमैच? शेडिंग. Now research area in partial shading is how you are going to simulate a moving cloud. आप यहाँ बैठे हो, आपको नहीं पता कि वो बादल उसके ऊपर आ गया पैनल के ऊपर. क्लाउड इज मूविंग, योर पैनल इज स्टेशनरी. मूविंग क्लाउड का आप सिमुलेशन कौन सी कंडीशन लोगे? यू विल एज्यूम फ्यू सेल्स शेडेड, दैट इज एजम्पशन पार्शियल शेडिंग में. मूविंग क्लाउड में जो डायनेमिक्स है वो उसमें नहीं आ रहा है, उसमें रैंडम पैटर्न आएगा. ओके, देन शेडिंग इज टू बी अवॉइडेड. शैडो फ्री एरिया में रखना है आपको, साउथ डायरेक्शन में रखना है, एटलीस्ट इक्वल टू एंगल इक्वल टू हियर, टिल्ट शुड बी इक्वल टू लैटिट्यूड. देन अनदर फैक्टर नॉन लीनियर डिग्रेडेशन. ऐसे आपको बारीक लाइंस दिख रहे हैं एकदम. आई टोल्ड यू दैट 2000 watt सिस्टम एट IIT बॉम्बे, सो वाज गिविंग 1200 watt. डिग्रेडेशन, उसका आउटपुट कम होने वाला है, उसका लाइफ 25 साल का है. द कॉस्टिंग मेथड इज लाइफ साइकिल कॉस्टिंग. Life, okay, so there levelized cost of energy is a key parameter in economic analysis. जैसे हमारे बॉडी में बीपी पैरामीटर थे, ओके, तो फास्टिंग, पोस्ट मील, शुगर, वैसे लेवलाइज कॉस्ट ऑफ एनर्जी इन इकोनॉमिक एनालिसिस. देन सॉइलिंग, डस्ट डिपोजिशन. आई शेयर्ड विद माय कलीग फ्रॉम सिविल, हु इज HOD नाउ. ही सेड सर आपके पैनल पे डस्ट होगा तो हम आपको एक हेल्प कर सकते हैं. हमारे स्टूडेंट आएंगे, वो ब्रश से एक बाउल में पूरी डस्ट ले लेंगे और जब पैनल पर डस्ट था तब आप परफॉर्मेंस देख लीजिए. वी हैव इंस्ट्रूमेंट गिव्स इंस्टेंट कर्व देयर ऑन द स्पॉट, एंड व्हेन इट इज कवर्ड विद डस्ट आल्सो यू कैन टेक. सो दैट डस्ट दे विल मेजर दैट बाउल इन देयर लेबोरेटरी, हाउ मेनी ग्राम डस्ट इज देयर. सो वी नीड हेल्प फ्रॉम अदर डिपार्टमेंट बिकॉज सिविल डिपार्टमेंट दे हैव एनवायरमेंटल इंजीनियरिंग. देन सॉइलिंग इज दिस, एंड टेम्परेचर डिफरेंस. अभी देखो कुछ डार्क है ब्लू कलर के, कुछ लाइट है फेंटेड, तो टेम्परेचर का असर हो गया. ओके, एंड दिस वेरी इंपॉर्टेंट एट नागपुर बिकॉज वेरी, ओके, हियर टेम्परेचर गोज वेरी हाई इन समर. धूप में आप खड़े नहीं रह सकते वहां पे सोलर रूफटॉप प्लांट के पास. यू वांट ऑल पैरामीटर ऑन योर PC और लैपटॉप टू बी डाउनलोडेड. ओके, सो और इन मोबाइल you want that. Okay, so what happened that in our electric maintenance section they have put up this solar rooftop plant on the girls hostel, boys hostel, and in summer they experience कि जो स्ट्रिंग इन्वर्टर है उसके ऊपर भले उन्होंने कैनोपी वगैरह कवर किया है, गर्म जब होता है टेम्परेचर हाई होने के बाद कैपेसिटर बस्ट हो गई. So getting that inverter replaced was a big task for them. So weather conditions are very important, and how we are going to provide cooling in summer, in May and June here on the terrace, because there is intense heat is there. So these are the factors. आपको सब फैक्टर का सोचना है. This is a new technology we don't have right now. मॉड्यूल के पीछे इन्वर्टर लगा है. छोटा जो ब्लैक कलर का बॉक्स है दैट इज योर मॉड्यूल शोइंग प्लस माइनस DC, एंड बिग बॉक्स इज अ माइक्रो इन्वर्टर. इट इज कॉस्टली, 35,000 का एक आएगा, हर मॉड्यूल के पीछे लगाना पड़ेगा. देन यू कैन हैव AC केबल. AC केबल कितनी भी लंबी होने दो, DC ज़्यादा लंबी नहीं हो सकती क्योंकि उसको ड्रॉप हो जाएगा. ये सब डिजाइन पैरामीटर इंपॉर्टेंट है. तो देन इट इज कॉल्ड AC मॉड्यूल. मॉड्यूल प्लस माइक्रो इन्वर्टर इज कॉल्ड एज AC मॉड्यूल. नाउ व्हाट आर द फीचर्स दैट आर गिवन हियर? इंक्रीज जनरेशन और स्ट्रिंग सिस्टम, safest solution with DC eliminated. On the roof, shading and soiling tolerant, most reliable. That is shown here. So this new thing we keep on updating our contents. This is single stage conversion जो हमने AC मॉड्यूल कहा है. वहाँ मॉड्यूल के साथ ही उन्होंने माइक्रो इन्वर्टर लगा दिया और फिर वो उसको एक इधर दिया है एनवॉय कम्युनिकेशन गेटवे AC पैनल को लगा दिया है. सिंगल मॉड्यूल ऑफ 48 volts DC माइक्रो इन्वर्टर्स. यू गेट AC electrical. Enphase company, you can check from the website. Okay. So this is a new technology. Startup is there. They have tested their product at IIT Chennai laboratory. आपको दोनों चाहिए, गर्म पानी भी चाहिए उसमें से और इलेक्ट्रिसिटी जनरेशन भी चाहिए on the rooftop. So you find here that cold water is in at the bottom. Okay, and due to gravity, that hot water will always be at the top level, hot water output. But at the same time, you are getting electrical energy. See, this is called as, okay, that PVT, photovoltaic thermal. They are using mono per crystalline cell, 72 cells, okay. then पैनल इलेक्ट्रिक आउटपुट 330 वैट. अब वो 330 वैट का मॉड्यूल हो गया, वो गर्म पानी भी मिल रहा है, सुटेबल फॉर दी कमर्शियल पर्पज. नीचे में उनका हीट एक्सचेंजर है, यहाँ दिखा है वैसे, ऊपर में पैनल है. ओके, दैट दे आर गिवन and the fluid volume and design everything is given. They are tested at IIT Chennai. This from Hyderabad, Bird's Eye Energy. They have indicated in their presentation that this is suitable for residential purpose. घर में आपको गर्म पानी भी चाहिए है, बिजली भी चाहिए. होटल्स में है, हॉस्पिटल में है, फूड इंडस्ट्री में लाइक हल्दीराम अदर, फार्मा इंडस्ट्रीज, केमिकल इंडस्ट्रीज, टेक्सटाइल इंडस्ट्रीज. And they are shown for residential how it can be implemented. And grid cost ₹6 per unit आएगा, वो भी उन्होंने लिखा है. 500 liter LPD, that solar water heater system, and they are shown for hotel also. So this we have not seen, but this is the need. Otherwise it consumes separate space. एक solar water heater की जगह ले लिया टेरेस पे, रूफटॉप सोलर प्लांट की अलग से जगह ले ली, ये 2 in 1 है. Okay, so we have to keep a track of this. That is shown and how to calculate or its life cost. Okay, that they are mentioned here. The technology tracking की 2 टाइप के होते हैं. Mechanical, you are tracking the panel by connecting motor, mechanical tracking. And what we talk about MPPT is electrical tracking. On that curve we want maximum power at every instant. Okay, you know that maximum power transfer theorem, that the power transfer will be maximum when source impedance is equal to load impedance. वो आपको हर instant करना है. Then on PV curve, okay, that you will have the MPPT. So this is mechanical tracking. You can track along the east west. तो सिंगल एक्सिस हो गया. आप ईस्ट वेस्ट नॉर्थ साउथ दोनों कर रहे हैं, दोनों डायरेक्शन में आपको ट्रैक करना है, तो 2 एक्सिस ट्रैकिंग. सो बट पार्ट्स रिक्वायर्ड आर मोर एंड रिक्वायर्ड कॉस्ट इज मोर, बट परफॉर्मेंस इज मोर. सो वी हैव ट्राइड दिस इन सिमुलेशन एंड वी हैव पेपर्स बेस्ड ऑन एमटेक प्रोजेक्ट. स्वाति शी इज वर्किंग विद सीमेंस नाउ. ये सब होने के बाद डिजाइन ऑफ ग्रिड कनेक्शन सिस्टम विच इज द टॉपिक ऑफ टुडे. And what is design criteria? So specifying a specific size. So when you go to any terrace, you have to take into account that there will be the area which will be shaded due to the parapet walls. You have to see that there is no nearby tree or a high-rise building. Then you have to calculate active rooftop area, जहाँ बिल्कुल शेडो नहीं आएगी, वो एरिया कम रहेगा, वहाँ इंस्टॉल करना है. So site visit is important. Available budget. Okay, so people know subsidy, but their budget is important. Available roof space. रूफ पर लगाना है, रूफ का टेस्टिंग करना पड़ेगा. लोड बेयरिंग, जमीन पे लगाना है तो सॉइल टेस्टिंग. ओके, देन टू डिजाइन दैट मॉड्यूल माउंटिंग स्ट्रक्चर, वी पीपल फ्रॉम इलेक्ट्रिकल नीड टू लर्न CAD. और स्टूडेंट डू नॉट नो, फैकल्टी डू नॉट नो CAD. Therefore they design complete system with number of panels and inverters and everything, but वो जो structure का drawing है, steel structure which is done using CAD, that knowledge, that skill is required. Available roof space, wanting to zero their annual electrical usage. My chartered accountant who files my income tax return, he is a non-technical person staying with joint family, parents. On first floor he has office, वहाँ उनके इंटर्नशिप के स्टूडेंट्स रहते हैं अकाउंटेंसी के. ओके, those who attend BCom and they are there in the office, all activities are carried out. Okay, and ground floor the family resides there. They have put a rooftop through reliable supply. उनको टेक्निकल कुछ नहीं पता है, उनको पता है कि ऑफिस में एसी लगे हैं, घर में एसी लगे हैं, बिल कम करना है. Then put rooftop, the electricity bill is reduced drastically. So that is the check. Okay. Then what is the final designer determining energy yield? We are going to share with you the formulas for this. Then inverter size based on the size of the array. How to decide what should be the input voltage feeding to inverter? There is some range, MPPT range. Matching the array configuration to selected inverter maximum voltage. That's what I am talking about. Voltage operating windows, because you can put say any number, okay, in the series to form a string, but ultimately वो string का voltage जो रहेगा parallel string, they will have common voltage, so same voltage that will go as the input to the inverter. So what is the inverter requirement? वो रेटिंग का इन्वर्टर मार्केट में है क्या, वैसे आपके डिजाइन करो, उतनी सीरीज में लगाओ, वैसे स्ट्रिंग बनाइए. Then engineering staff to visit the site. discuss energy efficient initiatives. This is the one initiative to reduce the electricity bill, put a rooftop solar. Assess occupational safety is very important. Okay, health risk, because when there is storm, तेज हवा रहती है बरसात में, हम टेरेस पे नहीं रहते हैं. So here in our department, the panel fell from the terrace on the ground floor. Okay, during the rainy season when there was storm. So then safety is very important. Health risks are there. So industry में एक ही रहता है word, safety, safety, safety. We visited the Reliance for earlier with the students, and they said every day is a safety day. Safety has no holiday. कोई छुट्टी नहीं रहती सेफ्टी को. सो सेफ्टी का ट्रेनिंग पहले होगा वो हॉल में, बाद में प्लांट में ले जाएंगे. 1.5-2 घंटा पहले सेफ्टी. ओके, डिटरमाइन सोलर एक्सेस, solar radiation, how it is available throughout the year. Determine whether any shading will occur, then orientation, south, tilt angle, fixed equal to latitude. Available area for the solar array. You may not have that much area and you talk about I want 10 kilowatt on my rooftop. जगह है क्या? Then whether roof is suitable for mounting the array. That is roof testing. That is very important. Nowadays the suppliers are coming to the flat systems and saying that we can reduce your common electricity bill. कॉमन में क्या है सर, आपका पार्किंग की लाइट सी है और पंप चलता है, पंप से ज़्यादा बिल आता है कॉमन का, वो कम करना है, हम वहाँ कनेक्ट कर देते हैं आप रूफटॉप सोलर. दे गिव यू सॉल्यूशन. In my flat system there are total 5 owners. Ground floor I am there, but one owner on the first floor is going to install the rooftop. We panel fix नहीं किए, and one on the second floor which is top floor he is going to install. हर एक यहाँ AC है, हर एक को बिल कम करना है. 2 लोग अभी करने वाले, अदर्स दे सेड कि वी वांट योर एक्सपीरियंस, देन विल डिसाइड. वी नो सब्सिडी, एवरीथिंग वी नो. वी विल जॉइन यू प्रोवाइडेड यू शो योर इलेक्ट्रिसिटी बिल. Okay, first you take the experience. So that is the need of the today, and determine where the inverter will be located. Your inverter cannot be located at the center of the terrace. उसको आपको एक स्ट्रिंग, पूरे स्ट्रिंग जो है उनको एक कॉर्नर में करना पड़ेगा, वहाँ शेड करना पड़ेगा, कैनोपी देना पड़ेगा. Okay, that is very important. Cabling route very important because people walk on the terrace. जो टॉप फ्लोर के वो मॉर्निंग वॉक वहीं लेते हैं. The cabling route is very important. Then estimate the length of the cable runs, how they are labeled. Okay, then whether monitoring panel screens are required to determine suitable location with the owner. Okay, or on mobile app nowadays we want. Then AC energy output we want. Then what are the factors that are mentioned here? This is the formula that gives energy yield, where we rated power output is the first factor at standard test conditions. Practically सेल टेम्परेचर 25 नहीं रहता है. ओके, इन विंटर इट विल बी लो टेम्परेचर आउटसाइड. एम्बिएंट टेम्परेचर विल चेंज योर सेल टेम्परेचर. इन योर सिमुलेशन वी कंसिडर दैट द इंसुलेशन इज फिक्स्ड, ओके, एंड टेम्परेचर इज वेरिंग, और टेम्परेचर सेल टेम्परेचर 25, इंसुलेशन वेरिंग. प्रैक्टिकली दोनों वेरी होता है. ओके, सो हाउ टू ब्रिंग दिस डायनेमिक कंडीशंस ऑफ द सोर्स into the simulation. Then the temperature derating factor, then derating factor manufacturing tolerance रहता है, due to dirt रहता रहेगा, yearly irradiation value and other factors with that. Okay, yearly irradiation value, efficiency of inverter, efficiency of the subsystem, efficiency of the cable between the inverter and switchboard, and solar irradiation as you measure. There is one factor, peaks and hours, which is 4 to 7. Now you have to see in this diagram 1000 watt per meter square. What is 1 kilowatt per meter square? For how many hours it is available on x-axis, that is mentioned, hours. So it is mentioned that number of peaks and hours here. Okay, this complete width, what you call it. If it is 5, then it is 5 called as 5 PSH. So this is very important, peaks and hour concept. 1 kilowatt per meter square आपको कितने घंटे मिलने वाला है. Therefore, generally 2 hours before 12 noon and 2 hours after 12 noon, they are very important. You want good radiation. And when you have the good energy yield from the solar plant, that time you will not have peak. You go to load dispatch center Ambadari, daily load कर में आपको morning peak मिलेगा around 8 to 9, evening peak जब street light शुरू होते हैं, लाखों street light city में, evening peak. That time solar energy is not maximum. Then what is the solution? Storage is suggested as solution or any other source. डी-रेटिंग में क्या होने वाला है कि आउटपुट कम होने वाला है ड्यू टू मैन्युफैक्चर टॉलरेंस रहेगा, डर्ट के कारण होगा, ड्यू टू क्लीनलीनेस, क्लीनिंग साइकिल वो मैन्युफैक्चर जिसने इंस्टॉल किया उसी की तरफ मेंटेनेंस, ईयरली मेंटेनेंस उसी को देना है. 15 दिन में आदमी आएगा, बोलेगा आपको नियर बाय टैप चाहिए, टैप है, ऑन टैप करेगा, क्लीन कर देगा, साइन कर देगा, चले जाएगा. क्लीनिंग साइकिल once in 15 days in VNet. Okay, they are mentioned how this factor reduces, that is shown in the red color. You can go through this because we don't have time. D-rating modules, that is the factors are indicated. The summary is indicated how final output power will reduce for 160 watt module to 122.74. ये हमें पता रहना चाहिए कि हमारा मॉड्यूल आउटपुट क्यों कम हो गया, क्या फैक्टर से. सप्लायर ने देते वक्त तो बताया था इतना 3 किलोवाट है, तो वन कैन ऑल्सो कैलकुलेट by considering factor. Then DC system losses, DC to AC ratio maintain करना है 1:1.1. Then DC energy that you will get, that you have to calculate. Okay, cable losses 3% only है. Inverter efficiency you have to calculate. AC energy delivered from the output of inverter you have to calculate. You can go through this. Check the AC system losses also they are considered, and energy yield they are calculated from this that way. And in kilowatt hour, energy and kilowatt hour per year निकालना है 365 days के लिए. Okay. Then specific energy yield by calculate numerator and denominator. The terminology was given earlier. The performance ratio निकालना है technical parameter में. Okay, it is the ratio of the SY with the ideal. Then the ideal energy you can calculate. Then performance ratio का example they are given. Considering PSH as equal to 5 peaks and hours, so how one can calculate the ratio, and here it comes out to be 70.7%. But generally आपको 79-80%. सेंट्रल इलेक्ट्रिसिटी रेगुलेटरी कमीशन CERC इंडिया में उनके जो रूल्स है वो रेंज में ही ये आना चाहिए. If they say 17 to 19% for capacity utilization factor, if they say for performance ratio, okay, 79 to 81%, you should get that. So these are the checks. Okay, inverter selection factors you can read this. Okay, that is inverter sizing, which is very important because maximum DC input power, maximum DC input current, specific output power. Inverter sizing example also it is given. You can go 160 watt ka array. Array comprises 16 160 watt PV modules. So total 2.56. Should the inverter be rated at 2.56 kilowatt? What is that one should know. Okay, मैन्युफैक्चरिंग का टॉलरेंस 5%, 0.95 हो गया, डर्ट का टॉलरेंस 5%, टेम्परेचर का बेस्ड ऑन एम्बिएंट टेम्परेचर. विंटर में एम्बिएंट टेम्परेचर कम है, सेल टेम्परेचर आपको फॉर्मूला से निकालना पड़ेगा. ओके, देन दैट यू हैव टू देन डी रेटिंग विल गिव यू दैट वैल्यू. ओके, दैट वे वन कैन कैलकुलेट. देन वोल्टेज विंडोज ऑफ इन्वर्टर, व्हाट वोल्टेज विंडो इज एक्सेप्टेबल इन्वर्टर, दैट इन्वर्टर विच इज अवेलेबल इन द मार्केट one has to prepare, and consider the MPPT range, which is very important. Minimum voltage of the inverter, that is very important, and maximum effective cell temperature of 70 degrees it can consider. Minimum voltage of the inverter with the value of VMPP as shown in the curve, and the inverter example they are given where EMPP value changes. Okay, due to the coefficient which is negative. Negative coefficient minus 0.177 volt per degree Celsius means temperature बढ़ेगा तो voltage कम होने वाला है. Negative, that is given by the manufacturer. Okay, then the example is given where they are solved with all steps. You can check how many modules finally you come out with that 5.79 means round figure to 6 modules. अब और फिगर मत लीजिए 7 9 ऐसा मत लीजिए, आपको स्ट्रिंग बनाना है 4 4 8 ऐसा लीजिए, 5 5 10, इधर 5 उधर 4 ऐसा नहीं होगा, वो स्ट्रिंग नहीं बनेगा, उनका वोल्टेज सेम रहना चाहिए पैरेलल. So what is available in the market one has to see, because inverter make कंपनी दूसरी है, मॉड्यूल में कंपनी दूसरी है, वो मैच करना है सप्लायर को सब. ओके, मैक्सिमम वोल्टेज इन्वर्टर also they are mentioned how it will can be calculated, and with the coefficient which are given in the data sheet they are indicated. Open circuit voltage at 15 degrees would be this much. Okay, so then assume the maximum voltage allowed by inverter is 400 volt. Divide the maximum number of modules in the string and you get a round figure to 8 modules they are considered, not 9, 8 they are considered, or 16 like that. So shadow का इफेक्ट होता है, shadow नहीं रहना चाहिए, ये हमने लिंक दिया है That is our paper, okay, based on MTech student work, that Karan Faldu's paper he has presented. You can download that. Assume maximum voltage allowed by 400 volt, maximum number of modules 400 by 44.6 that you got earlier, 8 modules you are getting. So therefore we should have 2 parallel sinks for 16 modules, 8 parallel or 8 आठ लगाना है. So shadow that is already. This is the details given in our paper. The scholar he considers the various configurations, series parallel, then honeycomb structure, bridge link, total cross tied, okay, then they are considered last one at the array system. So and here these plots you will get when you get multiple peaks, it is due to the shading. You don't, so then optimization problem you have to apply, which will give optimum value, because this will not give only one value, and therefore this problem is to be tackled. Okay, again here all condition one can consider, but they are assumed. Practically वैसा नहीं होता है. Moving cloud का condition क्या लोगे आप उसमें, आपको ही पता नहीं cloud कब आने वाला है, आप नीचे बैठे हो lab में. This is a Gujarat, that is okay 1 megawatt canal top, but after this I have not seen any other, but this is successful. Okay, floating solar plants are there by NTPC and others. Okay, they are installed, but we don't have trained manpower in India. CL and Terry is one company at Bangalore. They have installation at global level. Okay, then the hybrid floating, हाइड्रो पावर प्लांट में रिजर्वायर है, उसी में फ्लोटिंग लगा दो. अंबाझरी लेक में लगा सकते हैं, नागपुर म्यूनिसिपल कॉर्पोरेशन. We have 11 lakes. They should come out only at least small size plants so that people will have a tourist activity as well as educational activity. What is this new that is installed? Already they have garden lighting, उसी को जोड़ दो. So initially there may be some funding problem or issue, but this hybrid means we have two sources, hydro plus floating solar. Okay. So this example will be additional, but now I switch over to Sai. The Sai has to cover, Sai is there? The numerical sheet, so that you understand step by step what are the steps in the calculation. Okay, so numerical sheet you can share with them, and I will stop here. Sai will tell you along with his friend step by step approach to the solution. Okay, this is the additional problem that we can consider later on. So Sai, you want to give talk from this? Additional slides I will not cover, there is no time, because the students will cover the tutorial sheet and graphs you have. So you give the instruction, give him mic. You can circulate if you have Xerox, numerical sheet. They will give you step by step, okay, guidance. Only that we have parallel activity of PhD interview. And they wanted me to do for some time. There. Till you get the final solution, you don't leave this. Okay. At the most, you can have a tea inside also to save time. That is the case. So that yes, foreign expert will see. So I have to go there. See to it that they are comfortable, they get the solution. Okay, right? Is that? Okay. So if you want to write the formulas, you can open the slide. Whatever. Formulas you can write here. Okay, so that they apply the formula, mobile से करो, calculator से करो, formula लिख दो, question value कौन सा formula.
మాట్లాడదండి సాయి యువర్ ఇన్ లైవ్ యువర్ ఆన్ లైవ్ ఫస్ట్ టైం వేసి మనం ఇక్కడ నుంచి చేద్దాం. క్వశ్చన్ V peak, I peak, M peak, I peak, V peak. అవసరం లేదే, అది సొల్యూషన్ ఉందా? నువ్వెందుకు క్యాలిక్యులేట్ చేస్తున్నావు? అది సొల్యూషన్ చేసి వచ్చింది అది. Solar irradiation. Irradiation. Into area.
It is mentioned like STC. STC means standard test condition. Standard test.
1000 watts. My name is Vinay. Huh?
ఫస్ట్ క్వశ్చన్ అయిపోయి తర్వాత థర్డ్ క్వశ్చన్ నాకు just try the first question. Once you all try the question, we will solve it on the board. Market. So, listen everyone. Uh, So, for the first question, we have given open circuit voltage, VMP, short circuit current and IMP, and we have given the module dimensions. So, in the first question, firstly we asked you to calculate the fill factor. So, fill factor is this value. So, from this we can find the fill factor. So, next we ask for efficiency. So, efficiency is maximum power generated from the PV panel, then divided by the power we are giving to the PV panel, that is in the form of solar radiation. So, to get that power, we multiply the irradiation times the area of the panel. So, for the standard test conditions, we take the irradiation as 1000 watt per meter square. And we have given the dimensions. So, length and width and thickness. So, then area of the panel would be meter square. So, P max we can get from multiplying the VMP and IMP. So, with this we can find the efficiency. So, the next part of the question is, he has given, we have calculated the operating point with 35 as voltage and 7 as current in the normal condition, that is PV is directly connected to a resistive load. At this condition, we have operating point as 35 volts and 7 amps of current. So, with this we can find the value of R. V equal to IR, so we can find the value of R. Now, we are telling that now a boost converter is connected in between panel and the same resistor. So, Now a boost boost converter is connected with the PV panel such that now the PV panel is working at MPPT. That means we are extracting maximum power from the PV. That is this voltage as BMP and this current as IMP. So if we are generating maximum power from the PV panel, then the same amount of power the resistor is absorbing the same amount of power. So the resistor is now absorbing the same amount of P max power. So if this resistor, which is the same value as this, absorbing P max power, we can find what is the voltage across this resistor. So left side of the DC-DC converter, we have voltage as VMP, which is input to the DC-DC converter, and the right side of the DC-DC converter, which is the output of the DC-DC converter, is VO. So as I told you, the boost converter, for a boost converter, output voltage is equals to input voltage by 1 minus duty cycle. With this, we can find what is the duty ratio currently the DC-DC converter is working with. Anyone has any doubts in this question? All of clear with this? Now try to do the second question. Yeah, haven't they given you graph paper? Haven't they given you? Sai, graph paper? Did all of you done with the first question? Can we go to second question?
इधर देखना कम से कम अलाउड नहीं रहता नॉट अलाउड हियर सो फॉर यू वी आर सर्विंग टू सेव योर टाइम आपकी सेवा में है
Sir. So for second question, we have given the data points of voltage and current. So try to plot these data points in the graph sheet. So what you have asked to calculate the fill factor and efficiency. So how do we find to find the fill factor? We need VMP and IMP. To get VMP and IMP, try to find the power at each point. From there, you can get the maximum power. Yes. Respective voltage and current. Then you can find the fill factor and efficiency. And the next part of the question, we'll see after you have completed this fill factor and efficiency. No, sir. Any problem? Okay. They are taking. It's okay, sir. Just extend the graph to get VOC and ISC. You can just approximate the values. With your permission, can I go now move to the battery part of the question?
ये बराबर चल रहा है ये फील फैक्टर परसेंटेज एफिशिएंसी
I'll check with the actual answer, sir. I haven't written.
बोर्ड क्लीन कर दे बोल के सर
Okay, last part completed. हो गया.
बोर्ड क्लीन कर देना होने के बाद
So we have taken VMP and IMP as approximate values. So you can take the values that we have got from the plot. We have taken nearest values. So the next part of the question, when battery is connected across the panel, we have told that a battery is connected across the PV panel with open circuit voltage as 13.2 volts and internal resistance as 1 ohm. And at this condition, we don't know the operating point of the PV So let's consider this voltage as VPV and the current as IPV. So whatever be the voltage and current flowing from the PV, it should satisfy the KVL. So writing the KVL equation, this is the KVL equation. Okay, one last question, this second question, solve it. So now what do? We modify this equation in such a way. So this is the equation that we have got from the KVL. Now if you look this as in the IV characteristics, we have taken voltage as the x-axis and current as the y-axis. So considering this as the y and this as x, y equal to mx plus c, then you get a straight line equation. So this is the IV characteristic that you have plotted on the graph, and if you plot this straight line as this way, so this is the point where the system is satisfying the KVL and its IV characteristics as well. Now this point is going to be its operating point. This is the point where the system actually works. So for the third question, there is slight mistake. We also asked you to find the buck converter. No, you need not to find the buck converter. You only have to find the boost converter. The same way you have found for the first question. We will share you the answers in the WhatsApp.
Yes, sir. Continue. Good.
हाँ सर कर दो।
Thanks. Hello. Okay, so like before, let's have a look at what we covered this morning, right? Broadly, we should remember, and because they are thought points, right? That's how we think. So what are the first thing, what are the things we covered this morning? So if you can just randomly say whatever, it doesn't have to be in sequence. Doesn't have to be in sequence, you can say whatever you remember. Okay, so from this morning, what is it you remember? Yes? Why machine learning? Okay. Why machine learning? Okay. What do you remember about load flow? What do you remember about load flow? What if somebody was to ask you now, what is load flow? What will you say? Yes, loudly. Yes? Yes? What is the purpose of load flow? I mean, you can never forget that. What is the purpose of load flow? What is the type of equations we wrote? We said we didn't write, but we said we use these type of equations to voltage profile. Thank you very much. So load flow is used to get voltage profile. Thank you. Now, what was the difference between our circuit theory and load flow in formulating the equations? You have done it in your first year, second year, but here it is different. So what we identified as the main difference? Yeah, sinusoidal steady state, correct? That is the ideal case, that's perfect. But what is the difference? Pardon?
How do you represent the load?
How do you represent the loads? Etc., etc. So there are many ways to represent the load. If you represent it as constant current or constant power, then you end up with nonlinear equations. But if you represent it as constant impedance, this also is done. So it is done that some loads are this, some load are there, some load. So there is a distribution. So people, engineers who have got some experience. So obviously this is the best thing to do. Then this, then that. Well, solution wise, the easiest thing to do is constant impedance, then constant power, then constant current. Okay, so this is what we did, and we end up with a nonlinear equation. And what was the key? We had about nonlinear equations. When we end up with that, we had a 3-step process. Right? We identified a 3-step process when we have these things. So those 3 steps are very crucial. Entire world depends on those 3 steps. Anybody? Pardon? Loud? Okay, very good. Very good. Then, guess the solution then? Very good. I guess the solution, then what do I do? Find the error. Yeah. And then, third point. Pardon, बोले? बोले? क्या? Yeah, use this to find what? अपना plain language में बोले? Use this to find the next guess. Use it to find the next guess such that the error is reduced. Okay? Simple to remember, no x, no delta x. वो सब यूपीएससी का काम है, अपना काम नहीं है. Find the error, improve the guess. Right? We improve the guess, and that's how we keep doing, and then find the error, improve the guess. We keep doing it again and again and again and again. And our hope is that in every step we are reducing the error. Pardon? Continuous improvement. Correct. So that's how the thing goes. So now we had a classifier. That was our classifier, right? Y or whatever, y equals to that. No, z equals to that. Y equals to max 0 z greater than 0. This was our classifier, right? So what is the first thing we did about a classifier? How did we come up with the numbers W1, W2? Yes. Pardon? And B, yeah. So what do you remember? What is the thing worth remembering about the first algorithm? नहीं वो तो आपका ठीक है पर अपन ने once now we are in machine learning, right? So the first algorithm we saw today for finding the weights W1, W2 and B. So what was noteworthy about that algorithm? There was something we found that, oh, this is so exciting. We said that, okay, the people who thought of that algorithm, they went on television and all that. So what was so unique or noteworthy rather about that algorithm? Yeah? जोर से बोला. Single neuron, yeah, correct. Perceptor, yeah. Perceptron. Huh, yeah. Good, that is good. So what was unique after that? So we had a perceptron which was used as a classifier. So now we are saying W1, W2 and B. What was noteworthy about the algorithm which gave us these three numbers? What? Target? Target output. What do you mean? Target output से आपका क्या मतलब? सारी चीजें आपके सामने हैं. Desired value नहीं. आप बताएंगे क्या बात है?
Get output Y.
Why? Yeah.
To get the appropriate solution, but not exact. Means we will try to get the exact solution.
So okay. So वो सब secondary है. You are right. So the primary thing what is of interest is Y. So we use Y to train. That was that the network or the classifier is trained on its own. Am I making sense? We use Y, we don't use the true value or whatever, and we do the training. Right? So now, suppose we know the true value, what was the algorithm or what was the method or what was the technique we looked at to give us an improve the guess? What was the technique? Here improve the guess is a technique which is Y times X1, and here the improve the guess was W1 plus eta Y X1. So that was to improve the guess, right? In that algorithm. We had a look at something else. And we said this is what we can use to minimize this function. We had minimized the error between the classifier and the true value. So which was that? Can you name that that idea? Which is about the only idea we have in optimization. Yeah? So if you want to optimize a function, that's about the only idea we have, or find a root of a equation or whatever. That's perhaps the only idea we have. And what was that idea? एक idea था. You remember dot products and all that sort of business? We took dot product. तो dot product ने अपने को क्या दिया था? Pardon? That we linearized the equation 100%, right? And then we obtained something. That's right, but that method has a name to improve the guess. So we had, pardon? That here, yeah. मतलब ऑप्टिमाइजेशन का एक ही मेथड है. Pardon? Take a Taylor's theorem gave us something. Correct, 100% right. Linear Taylor's theorem, they are right. But what was the consequence of it? What did we conclude from there? We did Taylor's theorem, and then we said that this is the best way to improve our gas. Steepest descent. The Taylor thing and all told us that if we go in the direction of steepest descent, that's the best way to improve our gas, right? So steepest descent. These are the only few things you need to remember, right? So if you have a desired value and if you have got your output value, you get the error. To minimize the error, we have to change the weights in the direction of steepest descent. You don't need to remember much, that's about it. And that's the vocabulary we live with. Roti, dal, you can't go to the dining hall and say, oh yeah, ye kya, roti hai, dal hai. That is our working vocabulary, steepest descent. उसमें आप वो कह नहीं सकते कि अरे ये दाल है कि सब्जी है वो, that you have to know, right? And that's about it. Right? इसके सिवा कुछ नहीं है. Steepest descent or gradient methods are the only methods to do optimization. And why? Because we saw that those two vectors are aligned. When you change delta x in the direction of the gradient, those two things are aligned. Because they are aligned, the product is the largest. So it makes sense to change delta x in the direction of the gradient. And that method is called steepest descent or steepest ascent. If you are maximizing one, minimizing another. Good? So this should be our working vocabulary. Right? Good. So now where we are. Okay. So this we did that. Okay. Now, this is where things got stuck. There was a lot of excitement about classification techniques that machines will start thinking this and that, and everything came to an abrupt halt to classify these squares which are filled and squares which are empty. So squares which are filled have got one class and squares that are empty have got another class. So now what I want you to do is, I want you to have a linear classifier, just draw, not how, and see how you can separate the 2 points. Just draw it on your piece of paper. So this is 1 point, this is another point, and 1 point. So cross is 1 and circle is 1. So cross is one group, circle is another group. So how would you draw a classifier to separate the two? What do we need to do to separate the two? Draw a classifier, any type of classifier, linear, non-linear, whatever. Is there a classifier which will separate the two? See, we had a straight line which separated the two. Can you do? Firstly, can you draw a straight line which separates the two? And secondly, if you can't draw a straight line, is there any other shape you can draw to separate the two? अब क्वेश्चन समझ रहे हैं? यस मैडम, अब क्वेश्चन समझ रहे हैं? वी हैव गॉट 4 पॉइंट्स, राइट? जो डार्क है दैट इज वन ग्रुप, जो ब्लैंक है दैट इज अनदर ग्रुप. I want a classifier which separates them into 2 groups. करें, ड्रॉ करके बताएं, चले बोर्ड पे बताएं. हो सकती है, क्यों नहीं हो सकती? बिल्कुल, आप करके बताएं तो सही. क्लासीफाई ही करना है. So on one side, so the way we had classifier before, we had a line, उसके ऊपर एक क्लास, उसके नीचे दूसरा क्लास. We had that. And you can draw it this way, that way, you can draw it in 1,000 different ways. Okay? So tell me how you can do that. Yes, sir.
I was reading that.
Yes. So you are clear about the question.
Yes, I mean how to classify that. This is both two groups.
2 groups, and what is the geometric shape that will distinguish the 2 groups? The classifier simply is 2 different areas in the XY plane. In one area lies the one set of squares, in another area. So in one area lies the crosses, in another area lies the circles. That's basically it. I want to divide it into 2 parts. The coordinate plane, I want to divide it into 2 parts. One part contains the crosses and another part contains the circles. क्या मेरा प्रश्न तो ठीक है ना? So how would you do that? I want to divide it into 2 parts. You can use any geometric shape you like. Pardon? Pardon? कर दें, बोर्ड पे ड्रॉ कर दें. कर दें. अरे
फिर इसका ढंग से हो जाएगा.
हैं?
ये वाले का साइन में.
डन. क्या है? It has been divided into 2 parts. Is it or is it not? Done. खत्म. झंझट ही नहीं है. Thank you very much. So there are many different shapes, but you will realize that a straight line is not one of them. So straight line you draw here, you draw there, you draw there. No matter how you will draw a straight line, it cannot be put in 2 different shapes. Madam ने वहाँ बनाया है, that was quite good, but अपन इतना simple बना दें, right? आपने जो किया 100% right. There is nothing, nobody can find fault with that, right? So we divided the coordinate plane into 2 parts, one inside the circle, one outside the circle. Right? ठीक है? कोई मैं जादू तो नहीं किया? Okay. So now this is not a linear classifier. This is not a linear classifier. इसकी equation is not w1 x1 plus w2 x2 plus b. इसकी equation होगी x1 squared or plus x2 squared or things like that. It will be some funny classification, right? So now because it was not a linear classifier, things got stopped for several decades. That now we can't classify, and all the excitement just went down. That's such a simple, and this is called XOR, if you like, output. So we cannot classify such a simple thing, then what are we going to do? So it all came down. But then, people are always clever, more clever than you think. They came up with a neural network that will do the job. Yeah, so we had one perceptron, there are many perceptrons. Now, the genius was, okay, so came up with a neural network. Now, all of you know what is a neural network, right? So here, अच्छा आप सर हिलाया है तो हमको बताएं क्या न्यूरल, व्हाट डज दैट पिक्चर से, आपको आप बताएं व्हाट डज दैट पिक्चर से, क्या कह रही हो आपको, हिंदी में बोले कोई बात नहीं, मराठी में बोले, आपको मालूम है फिर क्यों झिझकते हैं आप? मैं 3 दिन हो गए किसी को खाया नहीं मैंने, राइट? हाँ तो बोले क्या, कैन यू हैव अ बिगर, व्हाट इज द इनपुट, व्हाट इज द इनपुट टू द न्यूरल नेटवर्क? x1 and x2, very good. And then what happens? I put x1, I feed x1 and x2 to the neural network, then what happens? W1, yeah. So then we need to keep going. We need to keep going from left to right, right? We need to keep going from left to right. So input is x1. So H1 is the what we feed to the next stage. What is H1? Yeah, what is the value of H1?
It will be the summation of both the inputs multiplied with their respective weights.
अब देख के बता दे क्या वेट है?
X1 W11
Yes,
plus H2 W21
yes,
equal to H1
yes. Very good. Plus B.
W1
Plus C1, sorry. Yeah. Correct. कोई इसमें तकलीफ नहीं ज्यादा. Good. Done. Now, so Z1 is that and Z से फिर H निकलता है. So that H is, what have I done? Okay. So H is a, okay. So that is max 0V, what we were doing before. Not 1 but max 0V. So what does that function, आप draw करें. Please draw this function in your notebook. This one. Equation 20. Draw करें. Function है ना? Just draw it. The input is V, the output is FAV. It is very hard to कन्विंस कि अगर आप ये खुद अपने हाथ से नहीं करते तो बाकी सब करने का कोई मतलब नहीं, because you have not got the basic. बाकी करते रहो करते रहो करते रहो, there is no, सबको IIC IIT में जाना है, that's the only difference. When you go to those institutions or any other institution which is top ranked, all they do is they do these things by hand first themselves. Yes sir. और दैट्स राइट. और उसके नीचे अब लेबल करें मेरे भाई, प्रेम से सब काम होना चाहिए. वी FAV प्रेम से करें लेबल, प्रेम से, ऐसे मजा नहीं आता. और अब व्हाट इज द वैल्यू ऑफ द फंक्शन फॉर V लेस देन 0? सो ड्रॉ कर ले वो भी, राइट? अब मेरे को इसका डेरिवेटिव बताएं. Then you draw Yes. Very good. Very good, sir. Good. कोई इतना मुश्किल तो नहीं है ना? Yeah, that's the biggest difference between institutes of repute, where students do everything complete. आधा खिचड़ी नहीं, शुरू से लेकर अंत तक एक चीज पूरी करते हैं. उसके बगैर आप कुछ सीख नहीं सकते. Okay, done. So, sir has said that this function is like that. Right? And then the derivative of this is 0. And ये इतना आसान काम नहीं है to get the derivative at this point. वो discontinuous है वो, तो थोड़ी झंझट है. So people who have done real analysis will know थोड़ी झंझट है, but for the purposes of our work, we assume that there is a sudden jump here at 0, right? The slope is 0 and it is 1. So if you want, if you are very particular, you can leave this out. Okay, if you are very particular, if you are mathematically very fastidious, because one discontinuity है, मैं भूल रहा हूँ थोड़ा, but there are ways to take care of that, right? But otherwise it's very straightforward, right? The slope is 1. Sorry, मेरी गलती है. The slope is 1 for positive V and it is 0 for negative V. ठीक है? And why are we mucking around with the slopes? लहर का पर्पज होता है ना. आपको ये लग रहा होगा कि ये तो खाली बोलता है, पर मेरी हर चीज का एक पर्पज है. कोई ऐसी चीज मैं नहीं बोलता जो रेलेवेंट नहीं है. तो बताएं कि क्यों मैं डेरिवेटिव और इन सब की झंझट कर रहा हूं. So what was the only method we knew to do optimization, to reduce error? Yeah? What was the only method we know? What is the only method we know to reduce a function's value? Pardon? आप जोर से बोल लेना अपने. हाँ, कुछ नहीं होने वाला. गलत हो तो भी कुछ नहीं. Steepest descent. So steepest descent, उसमें steepest descent में कौन सा ऑपरेशन, मैथमेटिकल ऑपरेशन होता है? Somebody said something. What is the mathematical operation we do? Derivative. Partial derivative we do. So that's why I have done the derivative. I have given the function value because we will likely use that, right? इसलिए ये सब झंझट किया. Now, so ये output y है. This is y. Without that, we would not have gone very far. So this is error, you would agree to that. Yd is our desired value. Y is our current output. उसमें तो कोई ज़्यादा झंझट है नहीं. And now we want to do something to reduce this error. What is it we want to do? Can you say it in words? आपने कह दिया है पहले, सुबह का. I want to hear it again. What is it I want to do next to reduce that error? What is it I want to do? Error reduction का क्या? What is the only way to reduce error? Yeah? बोल दें. Steep as descent. जोर से बोले, जोर से. Steep as descent. ये मैं मजाक नहीं कर रहा. It is to give you some confidence. अब ऐसे क्या उसका मतलब है? मतलब I want you to feel confident in yourself, you know, and you know that, I know that. So steepest descent, right? So steepest descent में आपको क्या करना पड़ता है? आगे, पढ़ा? Yeah, that's the consequence of it. But what is the mathematical function? Partial derivatives. Very good. Steepest descent, partial derivatives. And in this case, we'll take partial derivatives with respect to which variables? Yes? Very good. Very good. Weight, W1, W2 and all that, right? Yes, very good. Thank you very much. So we'll take partial derivatives with respect to the weights. W1, W2, W11, W12, W21, W22, right? We will take the partial derivatives with that, find out the steepest descent vector and change the values of the weights based on that steepest descent vector. ठीक है? कोई मुश्किल काम नहीं है? The reason why this is celebrated, this result is celebrated so much, is Widrow found a really clever way to do all this business. अब आप सोचें कि न्यूरल नेटवर्क, टिपिकल न्यूरल नेटवर्क हैज गॉट हाउ मेनी नोड्स? हजारों नोड होते हैं, राइट? एंड इट हैज गॉट मल्टीपल लेयर्स. So to do all that process systematically is what Widrow found. आप कर सकते हैं, you can have a vector with W1, W2 and have all the things, no harm done. But that will not end up to be so neat and clean. So Widrow gave us a method which is neat and clean. And what is that method? We have to see. So this is what we just discussed. I have put it here. Already we have discussed that. Okay. Updating W1. So we take derivative. So theta is the error. Did I call that? No, E is there. Because I think I've had enough in one lifetime. So it's E, not theta. मेरे को theta दिखा. So E. So delta E on delta W1. So I need to calculate. Is that the right expression for that? Please calculate. You know what is error? Please calculate and verify whether I have made a mistake or not. मैं बहुत गलतियां करता हूँ. You have to admire the beauty of this algorithm, to admire how neural networks are trained. Or unless you have a good understanding of how neural networks are trained, you will not be able to use it effectively. But there are so many parameters there. Okay, so ये सही है मैडम? सही है? So dy on dw1 is h1. dy, okay. dy, okay. dy, sorry. So why is this? Does it make sense that dy on dw1, del y on del w1 will be h1? ठीक है? ये लिख लें आप. Just write this expression so that we don't have to go backwards and forwards. Y भी लिख लें, ये भी लिख लें. Z1, Z2. Okay? Just write it out so that we don't have to. Okay, so now we have got the expressions here done there. Okay, so we have got algorithm to update W1. So same way you can do W2. You get the steepest descent. Delta is this learning term, which you can choose 0.1 or something like that. Do you have Y minus D available to you or not? When you are doing this training, do we have Y minus D available to us? Yes? Because we can use neural network to calculate Y, and YD is part of the data. So that's available to us. So this error is available to us. H1 is available to us, right? Because H1 is H1 is this. It's available to us. There is a definite process to find H1 given X1 and X2. H1 is available to us. So now we can use 26, right, to update W1. Correct? कोई इसमें ज़्यादा झंझट नहीं है. Very simple. Now we come to W11. So we are going back. Similarly, we can do W2. There's no problem. So just to keep it simple, I have done. But you should be able to. You should write W2 and all that, and make sure that you have got a proper expression for W1 and W2. Now I do 27. 27 is not an issue because Y minus YD, they are constant numbers. There is no derivative there. There is no change there. Only change is in Y with respect to W11. Okay. So now, ये simply मैंने लिखा है Y is H1 W1 plus H2 W2. So now in our case, H2 does not have W11, right? Correct? There is no W11 in H2. Z2 में W11 है? नहीं. So H2 में भी नहीं है. So when we take the derivative, we are only left with H1. So we do that, and then this is a chain rule, right? I take Z1 on W11 and then take the derivative of that thing with respect to Z1. So it is a chain rule. Okay? And you can do that. Now where do I end up? That is what I end up with. X1 I know, FA dash Z1 I know because I have got this rule here. Once I know Z1, I know the derivative, right? This rule is there. Once I know Z1, then if the Z1 is greater than 0, that number is 1. If Z1 is less than 0, that number is 0. Correct? Right? So that is taken care of. So updating C1 is a similar story. So we have updated W11, and this is where the power of this thing is. I have updated W11 in terms of what? What are the things? So very carefully look at all the things which are needed to update W11. What's needed to update W11? Count one after another. The original value of W11. Then what? Delta. And then what? Derivative function of that. And then what? W1. W1, right? So W1 we have already updated in the previous one. Right? We updated in the previous part, we have updated W1. Uska itna complicated equation tha. We just have done it. Now it is in our hands. So we don't have to make this equation complicated. As you keep going back and back and back, every equation is as simple as this. Because we are back propagating the weights we calculate. So we calculate updated W1. Now that updated value of W1 will be used to update W11. So this is back propagation. So it simplifies greatly in the sense the way you write it, because if you did the whole steepest descent, okay, so if there are 100,000 nodes or 4 layers, so you have to write your steepest descent with respect to all those weights. Now what we do here is we take the weights only of one layer and use those updated weights to back propagate the updating of the next layer. W1 when we update. Then we go back, and if as many layers are there, so this is just showing the principle that how the things are back propagated. And this is why Widrow is famous for giving that algorithm. It makes it so simple to write your computer program. Because once you updated W1, you forget all about the second stage. You focus the first stage, it is just as complicated as doing for one stage. So you do one stage at a time. And that makes your life very, very simple, right? And it is a very stable algorithm. If you did not do that, if you updated all the W's together, you can do that. There is no harm. You can write all the W's together and all that. Easily done. But that algorithm, it seems, is not very stable. In the sense, the errors don't reduce very fast. Back propagation for some reason, or I don't, my mistake, people have reasons, good reasons. Back propagation for good reasons is very stable. You update the rightmost things. Then you use those updates to go one after another till the end. And that's a very powerful algorithm, back propagation, and that's how all the neural networks are trained. So what do you know? What do you need to train a neural network? Again, what was the original process we started? What was our data? Yeah? Initial weights. What else? Our data. What data were we provided? X1, X2 and target. X1, X2 and YD, the target. We were provided. And you choose your own network. You can choose whichever network you like. So we have chosen this network. And now once the thing takes off, I mean, sky's the limit. So there are many, many different types of functions FAZ1. I think this is called RELU or something like that. There are many different types of FZs. Okay? And each has got its merit, not merit. And what type of function is that? That FAZ, is that a linear function? FAV, is that a linear function or non-linear function? Pardon? Non-linear function. And this, I must apologize, I have not come to grips with why this function is able to do this classification. It is the use of this function that enables us to do a classification like this, nonlinear classification. Right? So that is, so you choose different, those nonlinear functions, there are tens of them now, and you might get the same answer for everything, or sometimes you might get a different answer in training, sometimes you might get faster convergence in training. So all those things are there. So when you look at the neural network, they will ask you to say what type of function is this, FAV. They will ask you to choose this function. Okay, so you have to dig a little bit and come up with a function. This is what we are using, RELU. Okay. Okay, so this is the complete algorithm. H1, H2 to do W1, W2, because H1, H2 are the last things, the last nodes to update W1, W2. Then we need W1 and W2 to update all the 4 Ws. W11, W12, 21, 22. And that is a significant achievement in terms of making algorithms simple to write, and secondly, enhance convergence. When you do that, the convergence is very fast. You can update all the weights together. Nobody can stop you. If you strictly went by steepest descent, You can update all the weights in one go. Nobody can stop you doing that. Compared to that, this back propagation algorithm goes one step at a time. Okay, and that's why so what you see in front of you is why its glories are sung forever. So this is, if you apply this algorithm to that neural network, you will have this sort of classifier. Yellow is one region and violet is another. So that's a non-linear classifier. Right? So you do that, you are home. I think that's the last slide. Okay. अब आपकी मर्जी है, you want to do in the lab, you want to go home and do it, or because Srinivas will send you all the scripts, you can run the scripts at home, or we can load it in a common area now in the lab, and you can try it out, up to you, whatever you want to do. क्या करना है? तो घर तो सबको ही जाना होता है. कौन ऐसा नहीं इसको घर नहीं जाना? Up to you what you want to do. So you will try it out tonight. खाना वाना खाने के बाद. आज केबीसी है कि नहीं है? है? केबीसी रोज होता है क्या? कि एक ही दिन होता है? रोज? Oh my God! कितना समय की बर्बादी. तो कुछ लोग I know that they can't not watch KBC. उनको देखना ही अमिताभ बच्चन को. So I don't know what is your TV watching habits, but I would really strongly request that you run those, and all the details are there in this slide. The only mistake I have made is in that W1, W2, clockwise and counterclockwise rotation. That's the mistake I have made, which I have told you. Other than everything is fine, and I'll go home and email the corrected slides to you again. Okay, so करेंगे ना आप? थोड़ा सा खेलेंगे ना उसके साथ? हैं? You have to just run those scripts and see what happens, right? And then tomorrow you can ask me what does this do, what does that do, and all that. Very simple script. There is nothing really there. All the scripts only have these things. Scripts have nothing but these equations. That's all it is. And one thing we missed, what is the power of machine learning? Why machine learning is so sought after? Okay, maybe so, yeah, but उसकी क्या value क्या है? मतलब क्या क्यों people are crazy about that? What is it about it? Accurate, yeah, but machine learning से क्या संबंध है? Accurate तो कोई अपना बहुत ही very huge amount of data, yes, but correct, you are all right, but you get a very clever person, and a clever person can do many things. Pardon? Yeah, वो तो उसका outcome है. But what is it about the process? Very good. किसने कहा? Learning. So कैसे learning करता है बताएं? मतलब why? What type of learning does it do? Does it learn fast? Does it learn slow? It's not fast. It can learn tiny bit every time, but we can run it 1,000,000 times. Does not matter, because it's the machine. If there was a human being, we want every time we want fast learning, because then we are fed up. But if it is a computer, it can keep chugging. You would have done course in numerical solution of differential equations, करा होगा? रूंगे कुट्टा and all that? करा है ना? वो यूपीएससी का एकदम फटाफट है. उसमें सोचने की जरूरत नहीं, धड़ाधड़ लगाया हो गया. रूंगे कुट्टा and all that, imagine Euler. Euler solved those things by hand. this equation to do with planets and so many non-linear equations. He did it by hand, that Runge Kutta. Hand का क्या है? अगर यहाँ गलती हो गई तो it will propagate. You cannot correct it here. You have to go back here to correct that. ऑयलर की आपने फोटो देखी होगी, हमेशा एक ही साइड की देखी है, फिर उसकी आंख चली गई थी दूसरी साइड की करते करते. एंड ऑल दीज मैसिव कैलकुलेशंस उसकी बिल्ली ने जला दी. तब तो दीपक होता था ना, ऑयल लैंप, लाइट तो थी नहीं. तो हिज कैट टॉपल्ड दैट एंड बर्न्ट. ऑयलर जरा भी गुस्सा नहीं हुआ. He was not angry at all. हमको everybody is, many people are looking here and there. एक छोटी सी कैलकुलेशन वो हाथ नहीं जाता पेपर पे. ऑयलर ने करी रूम फुल्स ऑफ कैलकुलेशन और वो बिल्ली ने जला दी. कोई बात नहीं, स्टार्टेड अगेन. सो माय फ्रेंड्स, अगर जिंदगी में कुछ करना है तो मेहनत के सिवा कुछ नहीं होता, और आपको अपने हाथ से ही करनी पड़ेगी, कोई और नहीं करा सकता. दैट इज द ओनली डिफरेंस. द वे आई एम कवरिंग दिस कोर्स, यू माइट नॉट थिंक दैट आई एम कवरिंग बिग थिंग्स, बट जब तक ये नहीं करोगे बाकी किसी चीज का मतलब नहीं है. एंड दैट्स द ओनली डिफरेंस. यू गो टू स्टैनफोर्ड, MIT, IISc, IITs, that's the only difference. Their all emphasis is on fundamentals. जो अपन कर रहे हैं, their whole emphasis is there. और बाकी सब तो मैकेनिकल है भाई. Once you have this basic understanding, सब मैकेनिकल है, बट वो ढंग से सोचना पड़ता है, अपने पाप में कॉन्फिडेंस. The reason I see many people not doing it is because they don't have self confidence. यार गलती हो गई तो या होगी गलती. And yeah, we are all self-conscious. मैं भी यहाँ खड़ा होकर, obviously I don't want to make a mistake. I am also self-conscious. आप मेरे से कुछ पूछोगे जो मेरे को नहीं आता होगा, I will also hedge my bets. नहीं, ये नहीं, वो नहीं. That is very normal human. But in the privacy of your house, where you are not worried about लोग बाग क्या कहेंगे, do it. You know, so मैं तो जितना ये मेरी समझ इतनी है, I have no more. So tomorrow we will start doing hosting capacity. So we have got, so the reason I hesitate, I wanted to cover this is, those are polished scripts. They are ready scripts, they are working scripts, right? तो उसमें ज़्यादा learning नहीं है unless we know what those scripts are doing. That's why I wanted you to think about these things. कि क्या वो scripts कर रहे हैं, and then we'll look at it tomorrow. Okay? So we'll look at script to do hosting capacity tomorrow. Bless you, ma'am. Okay? ठीक है? Well, I didn't realize, मैं खाना खाने अपने फ्रेंड के यहाँ गया था, तो उसके बच्चे ने एक क्वेश्चन पूछ लिया. एंड बिफोर आई रियलाइज ब्लडी, मैंने 5 मिनट का उसको लेक्चर ठोक दिया. मैंने कहा, माई इनर्शिया from lecturing there, I am very sorry. So he works with our friend Ritesh.
Keshri.
हाँ, same company में. He has come from Denmark. He did his degrees in Denmark.
Okay.
So he's come back and he works with Keshri साहब.
क्या नाम है बेटे?
राघव.
सर.
राघव. So उसने कुछ मेरे को not technical, उसने कुछ और कोई बात पूछी तो मैंने ठोक दिया. So I am very sorry. हमारे नाना जी कहते थे, he was a teacher, school teacher, he has become principal. तो आप पता नहीं आप लोगों में तो क्या है, पर हमारे यहाँ झूठा उसका बहुत झंझट है. झूठा ना झूठा गा रहा है. So पानी ऊपर से पीना जो भी, तो people will do it, but he will be in the other room and tuck he will hear. अगर लोटा लग गया दांत से, so he said that जिंदगी भर मास्टरी करते करते ये आदत पड़ गई, अब जाती नहीं है. But he didn't want to say anything, he wanted to keep quiet. उनका यार आदत जाती नहीं है, वैसे ही मेरी आदत है. Okay sir, thank you very much. Come with me.
Yes.
And if you have any questions about this, we can do a Teams call, Sham ko. I'm quite happy to do it with you. You can get my.
When you will be able to share those?
सब हैं.
हाँ सर वो फाइल्स है सर स्लाइड्स वो स्लाइड्स के बारे में पूछ रहे हैं
Slides तो दे दिए ना.
हाँ
हाँ
आगे
करेक्शन
slides
कॉपी
हैं।
कर वो एक ही चीज है.
All of them they have all files.
यस सर
सब फाइल.
हाँ सर डे 1 फाइल्स सब
There is
है सर
assignment